Hello students, today we continue our lecture on organic chemistry. Although we have finished our syllabus, but as there are some questions and some doubts regarding the organic chemistry as well as the syllabus decodation, this lecture will be solely based on the syllabus of class 10 organic chemistry, especially the topic name IUPAC nomenclature. Okay, so in this lecture I gonna discuss about the syllabus of class 10 organic chemistry, that is the further reduced syllabus that provided by the council itself, and then we're gonna discuss about the IUPAC nomenclature of organic compounds. Okay, so let's begin. Here from this slide, although this slide is quite hazy, but you can see that here the chapter 9 consists of organic chemistry. This chapter 9 that only belongs to the organic chemistry, this chapter is being further reduced, and we can say that the reduction from this chapter is being quite huge. Okay, so although there are 5 sub points, that is the introduction to organic chemistry, the unique nature of carbon atoms and the tetravalency as well as catenation power, and the formation of single, double and triple bonds compounds. This is the point number 1. Point number 2 says the structure and isomerism. Okay, point number 3 was about the homologous series, that is the alkane series. Okay, that is a single bond, double bond and triple bond compounds. And point number 4 says the simple nomenclature, that is the IUPAC nomenclature of compounds. Okay, as well as trivial names. And the last point says that the hydrocarbons, that is the alkane and alkynes, and some reactions of it. Remember, the preparations of alkane and alkynes are not in our syllabus. They are removed from the syllabus as well. And in our previous syllabus, there was some alcohol and acid part in our syllabus, but those part are being removed by the council as well. So we need to consider these 5 points to be discussed in the brief. This chapter mainly consists of 3 parts. That is, number 1 is IUPAC nomenclature. Number 2, isomerism. And number 3, that is a homologous series and some reactions of it, that is alkane and alkyne. Okay, so these 3 parts are important. I have already made a video of isomerism and the alkane and alkyne, this part about their properties and their behavior. So to do the revision of this chapter, I like to mention the syllabus of this chapter so that you get a clear idea what to read and what not to read for your upcoming exams. And right now I will be discussing about the IUPAC nomenclature. We should first deal with the IUPAC nomenclature rules. I have made it quite simple so that you get a clear idea about that, and then we will discuss some problem as well. Okay, so let's start. Here in this slide you can see that the IUPAC nomenclature does have some rules. I have written it in my language so that you get a clear idea. Okay, so you can just do any kind of organic nomenclature after going through these points or these rules. Okay, so the point number 1 is look for the highest carbon chain. Okay, so there will be, suppose this is the carbon chain, that this carbon, this carbon, this carbon, this carbon, this is a carbon, this is a carbon. Okay, so here you can see, if we number the carbon from here, the number of carbon will be 1, 2, 3 and 4. So if we go from here to there, we will get only 4 carbon. Okay, but if we go from 1, 2, 3, 4 and 5, then we will get 5 carbon as a highest carbon chain. Okay, so number of carbon, where the number of carbon is highest, that will be the main chain of carbon. Okay, so here if we go like this only, in this way we will get only 4 carbons, but when we go like this only we will get 5 carbons. So we can take this chain as our main carbon chain or main organic carbon chain or highest carbon chain. Okay, so this is the way to do the first step of IUPAC nomenclature. Then look for the functional group. And what is the functional group? Those are those groups which can have a certain physical and chemical properties when they add to a carbon chain. Okay, so certain groups or certain molecules or certain atoms have some particular amount of property, or particular or distinctive amount, distinctive properties. That properties can only be shown when those groups are there in a compound. So those groups are being called as functional groups. Here the functional groups are mainly fluorine, chlorine, bromine, iodine, double bond, single bond, triple bond, okay, as well as the CHO, that is the aldehyde, C double bond O, that is the ketone. And remember, the C double bond O, this group is being called as a keto group. Okay, so this group is being called as only a keto group. Okay, and the compound having the keto group is being called as the ketone. Okay, so see, any compound having C double bond O, and while apart from C double bond O, if the both side of the C double bond O, that is the keto group, this is being called as a keto. This is being called as a keto group. Okay, so if there is carbon in the both side of the keto group, then it will be, the compound will be called as ketone. Okay, if there is carbon in the both side of the keto group, then the compound will be called as ketone. Okay, if there is, okay, let's take another example. Suppose here one side is being carbon, other side is being hydrogen. So if there is any hydrogen present in the neighboring position of keto group, this is the keto group, and in the neighboring position one hydrogen is present, then it will be called aldehyde. Okay, so that is the difference between aldehyde and ketone. So aldehyde consists of keto group as well as ketone. It's also being consisting of a keto group, that is the C double bond O. The difference lies in between them, where aldehyde having a keto group consisting of hydrogen, but ketone, there is no hydrogen in the ketone. Okay, so that is the difference between the aldehyde and ketone. Okay, so they are being called as the functional group. And the point number 3 is carbon containing the functional group should be numbered first. So take an example of that, that is CH3, CH2, CH2Cl. Okay, so here you can see that the Cl, that is a Cl is being present, so it is a functional group. And so we can number this carbon chain from this side and this side from here. So if we take a number from that, then 1, 2 and 3. So in carbon number 3 we have the functional group, but this is incorrect. Okay, so we have to do what? As the functional group is here, so the number of carbon, so the numbering of the carbon should start from here, that is 1, 2 and 3. So remember, the carbon that containing the functional group should be numbered first, so that will be a group number 1. If the carbon containing the functional group is in the middle, that it doesn't matter. Whatever you do, there is 1, 2 and 3, or here from the right hand side it will be 1 in the number 2 carbon, that is chlorine is present in number 2 carbon, and from here it is also present in number 2 carbon, so it doesn't matter in the middle. Okay, but look for the carbon that contains the functional group should having the least number. Okay, so suppose here, let's give an example of CH3, CH2, CHBr CH3. So here if we take the number of carbons from here 1, 2, 3 and 4, the longest chains contain here. But here in the position number 3 there is C3 carbon containing the functional group. But here if we take from here to there, that is from right side to left hand side, so what happened, number will be carbon 1, 2, 3 and 4. Okay, so here in the C2 carbon holds the functional group, that is a Br. So here in the least position is C2. So the carbon numbering should be, this will be the right numbering of carbons, not that one, because look for the carbon that contains the functional group, the numbering of the carbon of that carbon will be least. Okay, here in that position, that is the blue color one, in that position the carbon number is being lowest, so it is the correct one. Okay, I hope you have understood. Okay, so the next point is add the suitable prefix or suffix. Okay, here in the case of CHO, the CHO is being discussing about the CHO is being called as aldehyde. The suffix will be plus L. Suppose that is called as CH3CHO. So number of carbon are 1 and 2. Okay, so this is being CHO is being the functional group, so it is being 1 and it is being 2. So this number of carbon are 2. So it is being called as ethane. That is ethane plus L, ethane plus L, ethanol. Okay, ethanol. Okay, and similarly here in this it is, if it is a ketone, that is CH3 C double bond O CH3, as you know, that is the C double bond O consisting of 2 and having the neighbor 2 carbon groups, so it is being ketone, and whatever the numbering is from here to there, both will be the same. So here in the position number 2 the carbonyl group is there. Okay, so the number will be, as the number of carbons is 3, so it will be, as we know, meth, eth, prop, so propane 2 on. Okay, so here 1 E, that is propane, is being consisting of PROPANE. Okay, so here this E part will be removed. Propane, that is this E part will be removed in the case of aldehyde and ketone. Then for aldehyde it will be plus L, and for ketone it will be plus on. Okay, in this way the remaining numbering will be, or remaining name will be considered. Okay, and let's go to the carboxylic acid. Suppose here CH3COOH. So it is a containing a functional group COOH, as the functional group is there, and the numbering start from here to there, and then the number of carbon is 2. So it will be meth, eth, ethane, and this E will be removed, plus oic acid, as that is carboxylic acid. So ethanoic acid. So the name will be ethanoic acid. Okay, and one example I have to do for the alcohol as well. So let's take an example of CH3 CH2OH, and this OH is the functional group. As you know, this OH is a functional group and it is being bonded to this carbon, so this will be number first 1 and 2. So what will be the name? As it is a number of carbon is 2, so it will be ethane, and this E will be removed, plus all. That means for alcohol it is being suffixed with all, so the name will be ethanol. Okay, so this is the way to conduct the IUPAC nomenclature of the compounds. And let's take some example of homologous series, that is suppose CH3 and CH2 CH3. Okay, so remember, if you see there is no double bond, there is no double bond or triple bond is there, no double bond and no triple bond is there, no triple bond is there, only single bond is present, then it will be alkane, then it will be a alkane, and name of the alkane will be depend on the number of carbon. Here the number of carbon is 1, 2 and 3. So as the number of carbon is 3, so it will be propane. Okay, and so look for the, here in the case of homologous series, there is, if there is no functional group as such, that is fluorine, chlorine, bromine, iodine, or COOH, CHO, or CO rather. So if you have to look for the double bond or triple bond. If there is no double bond or triple bond, that will be alkane, and the name will be according to the number of carbon. Okay, so let's move to the next. It is CH3 CH double bond CH2. Okay, so here the functional group, we can see the functional group is here. So number, the carbon number first, then this, then that. So the number of carbon is 2, and look for the double bond and triple bond. As there is double bond, so that will be a alkene. Remember, at least one double or triple bond can make a compound alkene or alkyne. Okay, here one double bond is there, so it will be alkene, and the number of carbon is 3, so propene. So name of the compound will be propene. Okay, and let's move to the next example. Let's take an example of alkyne, CH3 CH triple bond CH. Okay, so what will be the name numbering? As we can see, the functional group is, this is the functional group, so the number will be 1, 2 and 3. And as there is one triple bond is there, so it is alkyne. Okay, and the name will be, as there is number of carbon is 3, so propane, that means propyne. Here ine part will be added. Okay, if the number of carbon is 2, that is CH triple bond CH, that is being called as acetylene. This is the formal name, acetylene, and the IUPAC name will be 1 and 2, and this is a double triple bond, so it will be alkyne, so it will become ethyne. Okay, so in this way we can do the IUPAC nomenclature of the organic compounds. Okay, so this is the preliminary idea and the basic idea of the compounds. I hope you have understood this part and how to do the IUPAC nomenclature. If you have any doubt regarding this concept or this chapter, please ask me in the comment section below. I'll be happy to help you. Okay, so that's it for now. Thank you very much. Bye.